independent events on video 67.
Awesome.
Yep.
We're gonna hit 100. We're gonna bust 100. I don't know what 100 will be.
Well, we're gonna hit 100 pretty soon.
It'll be on probably hypothesis testing, probably around there.
Good old hypothesis
before
testing. Whether you reject, fail to reject.
No, we'll hit 100 before that. Okay. Anyway,
All right.
mumbo jumbo.
Okay, so to go through independent events, we got a few examples. First, we have a clothing store that advertises during a grand opening. Every customer that enters the store can throw a bouncy rubber cube onto a table that has squares labeled with the discount amounts.
All right, Lewis, I gotta admit this has never happened to me.
Yeah, me neither.
You ever walked into a clothing store at the Hip or someplace?
I don't shop around here.
What's that?
I don't go to stores. It's all, I buy everything online.
The mall near me sucks, but there's the Hip, there's the
all malls suck.
Old Orchard or someplace. Anyway, they haven't done this, but suppose you got a table that looks like that. You walk in, roll the bouncy ball, whatever it lands, that's the discount you get.
Right. So you get 5 with 10%, 2 with 20%, 2 with 30%, and then the big winner, half off.
You know what this could be? This could be like someone who's a math teacher who retired and opened their own clothing store.
Could be, but I doubt it.
All right.
All right. So what is the probability that a customer gets more than 20% off?
More than 20.
Yeah.
That doesn't include 20.
No. More than.
Well, I see a 30 and a 50.
And
So
yeah, so there's 2 30s and a 50.
2 out of 10.
I mean, 3 out of 10?
Are they?
There's 2 30s.
Oh, they are. I'm sorry. 3 out of 10.
Okay. We're there. Just takes Mr. Miller a while to wake up.
It is Friday. I don't know what day it is for you, but it's Friday for us.
All right.
So 30% chance. That's pretty good.
Yep. What's the probability that the customer gets less than 20?
Is that the compliment?
No, because we're still not including 20.
Very sharp, Mr. Lewis. He's got it today.
Yeah.
So we've talked about more than 20%, less than 20%, but we haven't yet included equal to 20%.
Right.
So
Okay. This would just be 5 out of 10 or 1/2.
Got it.
So half the time you're just going to get 10%.
Which is still good.
Mm-hmm. Okay. So how about if we do, what's the probability that the first 2 customers get a 50% discount?
Now we're talking.
Yeah. So now we get a little more challenging. So
Are they independent?
They are.
And what would that mean in this case?
That means that the probabilities would be the same each time.
Yeah, it means like the first person who throws a bouncy ball doesn't
Right.
really affect the second person who comes in and throws the bouncy ball.
Exactly. So we have, person 1, and then, person 2. They're going to come in right after them. Okay? But yeah, how they throw the ball, it's not like the ball then sticks and goes to 50% more.
Yeah, so these are independent events. It's an intersection. The first person gets 50% and the second person, this is law number 3.
Yes.
So the law for intersections, we're going to multiply these probabilities. So it's going to be 1/10, and
And 1/10.
we're going to multiply. So put a big dot in the middle,
Yep.
and that is 1/100.
Yep. So
So
odds
a
are
1% chance.
Yeah, odds are not very good that that's going to happen.
2 in a row. Okay. 4. What's the probability that none of the first 3 customers gets more than a 30% discount?
Well, that would just be the 50% off would be the more than. So again, we have person 1, person 2, person 3.
And so
So
none of them gets more than 30%. So
the only thing more than 30% is that 50%.
Right.
So it'd be everything else.
So there's a 90% chance. So 9
yeah,
tenths.
9 tenths, 9 tenths, and 9 tenths. Okay. Well, the bottom thing will be 1,000. What's 9 cubed?
729, I believe.
729.
Yeah, that's just coming from memory. Man. I'm just guessing. So make sure I'm not lying.
We'll try and go with it.
It is 729.
Okay.
So about 72.9%.
See, he sharpened back up.
Right. Let's see if we can hold it together. What is the probability that the first customer to win a 30% discount is the 6th customer? All right, so 30% discount is 2 out of 10.
Right. That's 2 out of 10.
Okay, so let's
The
write.
not is 8 out of 10.
Yeah, so the first person is 8 out of 10.
Right.
And
8
then,
out of 10.
and maybe put some parentheses around it. Or there
Yep.
you go. times another 8 out of 10. Boy, you're going to wish we used an exponent. That's
Yeah,
the second
I am.
person fails.
That's what I thought you were going with the
Third person
parentheses. But no, you're going to make me write in each one.
You know, it's very visual this way. It makes you
8
appreciate
out of 10.
exponents. One more, Mr. Lewis. You stay strong.
8 out of 10.
So that's the first 5 people fail.
And then
The last one.
gets it.
This is actually an example of what's called the geometric model.
Yes.
Problem. And we'll be talking a lot about that soon. All right. So the first success, as in the first person to win the 30% discount, on the 6th try, that would be the probability.
Right.
Oh, okay.
Yeah, I'm going to need a little help here. I'm not that good.
You know, to be fair, I should enter it the same way you did, but I'm going to use exponents.
Oh, I see.
I get 6.55%.
Okay, so 0, oops, 0.6, oops, 6%. I'm sorry. This is
Yeah, 6.66 or 6.55%.
0.065%.
Very good. Okay. Next.
Okay.
There's a lot of problems.
Yeah,
here.
we're going to use some exponents this time because I'm not writing that much again.
What is the probability that there is at least,
Ooh.
you know what we have to do when we stop? When we see the words at least, we have to stop and do something. You got to stop and have a heart attack is what you have to do.
Yeah, because it's going to be a lot.
So those words at least, they're trouble.
Right, because that means one customer could have it, 2, 3, 4, or all 5.
So at least one. Now, what's the complement of at least one?
None.
So let's write the rule. Probability of a complement, and then we'll show how it applies. This is like the first probability law. Probability of the a complement. No, not conditional.
Oh, I'm sorry. A complement. I'm
A
sorry.
complement.
Probability of a. See, now I'm losing it.
It's contagious.
It
Equals
is. Equals.
1 minus the probability of a.
Right.
Or you can switch them if you want. So what we can do is compute the complement of this event and subtract it from 1. So the probability of at least 1, so I don't know if you want to write P, probability of at least 1.
P
At
at least 1 is equal to 1 minus the probability of none.
And it's because probability of none is a lot easier to compute. So it'd
Right.
be 1 minus
So it'd be 1 minus
0.9.
0.9 to the 5th.
Very good. We got this.
Because it's a 90% chance we're not getting a 5. And what is that?
It's about 41%.
So there is a 41% chance that somebody's walking in there and getting a 50.
Of the first 5.
Yes.
Yeah.
Of
can't
the
be-
first 5.
So,
Yes.
so
Gotta be
ready to
specific.
give that away.
Right.
Okay. Now, as you enter the store, you watch the 4 people in front of you all win 50% discounts.
That must be nice.
High rollers. The store manager tells you how lucky you are to be throwing the cube while it's on a hot streak. But the friend with you says you're unlucky because the streak can't continue. So one person says the streak can't continue. It means like you're due to fail.
Right.
And the other one says the dice is hot, so you're more likely to succeed.
However, we know these are independent events, so there's no such thing as a hot die.
Yeah, neither of
And-
them took AP stats,
Right.
apparently, on there.
It's you have the same chance of getting a 50 as everybody else before you. They were, maybe a little luckier than you, but I mean the chance is still 1 out of 10.
So you should walk in the store and say, is there someone who took AP stats I can see?
Yes.
All right, of course.
Uh-huh.
So these are independent trials.
Right.
So the chance is and always will be 1/10 of getting a 50%.
Right.
So just because you had a streak of 50%, we're not saying that's likely or that's unlikely, but that doesn't mean that that changes the probability of the next one.
Right. Always a 1
And
out
like
of
I said,
10.
you could flip a fair coin
chance.
10 times and get 10 heads. It's unlikely, but it could happen. But that 11th time is still 50-50.
Yep. It's
Okay.
true.
So the cube doesn't have a memory.
No, it does not.
Okay. Mr. Lewis, we made it.
I think so.
Journal time.
Yep. It's
What
time
do we
for
got
the-
here, Mr. Lewis?
Well, we have a lovely little wheel of savings spinner. This is like,
Now, if we were really cool, a little Vanna White would pop up and like spin that or something.
yeah, but I'm not that good of a programmer.
All right.
So here we have a wheel divided into 12 regions, just like a clock. Okay, and we have all these different discounts, and this store is even better because we get this 100% right up there.
It's free.
Yeah, free stuff. So the first one says, what's the probability that the customer gets at least a 40% discount? That's one of those at least ones.
Yeah, but this one's not so bad because
No.
it's not involving multiple spins.
No, it's just one.
All right.
But I just wanted to try and scare them a little bit.
Oh, okay. Yeah, just for practice.
Yeah. What's the probability that the two customers in a row get 10% discounts? What's the probability that three consecutive customers get 20% discounts? Remember, consecutive means back to back. Okay. And what's the probability that none of the first four customers get a discount over 20%? So, we can figure those out, and we can kind of talk through them tomorrow.
All right. And or Monday.
Oh yeah, that's right. It's a week.